Welcome folks, I wanted to introduce a new tutorial on Orcad, and here we are moving to version 17.4. so it's a new software environment. There is new changes to it, so if you are new to Orcad PSpice, then this is a very good point to start learning how to use PSpice simulation using Orcad. However, if you are switching from an earlier version like 17.2, then this also will be a very good starting point for you to see what's the differences are between the older version and the new version. Now the icon for the CIS capture for the new version going to be this one over here. So I'm going to click on it and the new version going to start. So as you can see that the window have popped up. From the first sight, it seems that the software is completely different from the previous version. However, once you start to work with it, especially when you do PSpice simulation, you're going to see that there is a lot of similarities between the old version and the new version. There is great improvements in the new version, I believe. Especially on the PCB design. So as you can see that Orcad is a complete design tool. It's not just for circuit simulation, but a complete design tool. It has things has to do with schematics. Schematics means to draw the circuit. Drawing the circuit, the interface that allows you to draw the circuit and the schematic. And then we have PSpice simulation, which is responsible for simulating the electronic circuits. And then it does also PCB design. In fact, that Orcad combines the PSpice simulation and the PCB design to deliver a complete hardware solution. There is also existing library. They have a huge library, and that will save time for the designers. However, I use PSpice simulation in my courses, so I will be focused on PSpice simulation and how to draw schematics and so forth. So when you load PSpice Orcad, that's what you're gonna have. And then one of the toolboxes that we have is this one here that deals with the PSpice simulation, and it's over here. So I'm gonna move it the way I like it. So I'm gonna move it over here. You don't have to do that, but I will move it. Let's see, I want it to be the second row. There you go. And then let's move it this way. I'll move it more like that. This is the way I like it. We're dealing with the simulation gonna be basically the second row of the toolboxes that we have. So I'm gonna start with a new project. So I can go to File, click on New Project, or I can click this icon where it says New Project. I like the menu, so I'm gonna go to File, New, then a New Project, and I will give this project a name. So I will call it First Simulation. Let's call it PSpice 1, and I'm gonna click OK, and I'm gonna create a blank project. So here what we have is basically going to be analog or mixed analog digital PSpice project. And over here where we have the hierarchy of the design, so this is the schematic where I'm going to draw the circuits, and then I will assign simulations to it. So the first thing I'm going to do is I'm going to basically add parts. So I'm going to come over here. This icon will be to add parts. So I'm going to click on it. And here I don't have any libraries, so I have to recall libraries that already exist. So I'm gonna click here on Add Libraries. So I will add libraries to my project, and I want to make sure that when I click on it that I'm under PSpice, because PSpice means circuit simulation. So I want it to simulate circuits. So the first one I'm interested in is the sources. That basically has to deal with the voltage, current sources, and so forth. So I'm going to add this library. It's under source OLB. So I will click that. I'll say open. And now you can see that you have source library, and it shows us all different type of sources that we can use. I'm actually interested in this particular simulation in DC voltage sources, and I'm going to talk about that shortly. So I'm going to also add another library. So I will come here to this icon. I will say add library, and now I'm interested in the analog library. So I will do analog. So here is my analog library, and I will open that also. If in later projects I'll be interested in op-amp libraries. So here is op-amp libraries. And also, if you are doing some electronic circuits, I'm interested in the bipolar junction transistors. So I can also add, I believe, bipolar library. So those library names changed from the previous versions. I recommend you to use those new library names. I think this is it for now. The analog library will have components like resistors, capacitors, inductors. So those are the analog components that I would like to use. The op-amps will have components for different type of op-amps that we can use to do PSpice simulations. Bipolar have different models for transistors. So if you are taking basic circuit theory, what we are interested in is the analog and the sources. The design cache basically is the libraries that are used within our schematic. So now what we're going to do is we want to draw a very simple circuit and do basic PSpice simulation. I'm going to select all those libraries so I can use them all. And the first thing I'm going to be interested in is to use DC voltage source. So I'm going to come to part here, and I'm going to write VDC, and that is shown over here, VDC as a source. I'm going to double click on it, and it will be shown on the schematic screen, as you can see here. As soon as I double clicked on the VDC source, it became here. I'm going to click on it, and now I have basically placed a DC voltage source. I am going to change this value to make it, for example, 15 volts. So now I read 15 volts DC across this element. And let me zoom in a little bit. So I'm going to click in here a little bit to see that I'm zooming in into this voltage source. I can move this value if I want it a little bit. And the name of the voltage source is called V1. I can move it here also. Now I'm interested in adding a single resistor. So this is a very simple circuit I'm trying to build, which is one resistor and one voltage source. So the resistor here is laid out horizontally. I'm going to click on R to rotate it. So now it's going to be laid out vertical like this. And the resistor has a name R1 and the value is 1K. Now I can change this value to 2K. So I'm going to click on it, and I'm going to make it 2K, and I will click on OK or hit enter. So the value now changed to 2K. Now I need to draw the circuit. So basically I'm going to draw a wire from the voltage source to the resistor, and then another wire from the resistor to the voltage source. So this icon here where it says place wire, I'm going to click on it, and then I'm going to come in here from the voltage source. I will connect it to the resistor, and then from the resistor to the voltage source I will also connect a wire. Now this circuit is not complete yet. We need to define the 0 volts, which what we call the ground. That's extremely important when we do PSpice simulation. So I'm going to come to the icons over here. One of them going to be grounds. Place a ground here. So I'm going to click on it, and I'm going to use the zero cap sim. That's the one I'm going to use, zero cap sim. So I'm going to place this here. If you use different ones, the simulation will not work. Now this is extremely important. You need to add this ground here to your circuit schematic. So now what we need to do is we need to use the first type of simulation to simulate the circuit. So the first type of simulation is what we call bias points. Bias points basically says that it will measure the DC values along each point in the circuit. It will tell you that what's the DC voltage, current, or power of the voltage source and of the resistor. So to do that, I need to create a new simulation. So this second row is my simulation toolbox. So I'm going to come to the first one here. It says a new simulation profile. Basically, I'm going to add a new simulation. So I'm going to click on it. And now it says that give your simulation a name. So I'm going to give it a name Sim1. That's my first simulation. You can give it any name. It's not inherited from any previous simulations. It's just a new simulation. I'm going to click on create, or you can hit enter. And now we have the interface of the simulation. So what I'm going to do here, where it says the simulation type, the first type of simulations we are interested in is what we call bias points. So I'm going to click on bias points, and it's going to be in the general settings, and that's it. That's all what I'm going to do here is bias points. I'm going to click on apply. OK. So now I have created a simulation called Sim1, and I selected the bias point option. Now I'm going to run the simulation. To run the simulation, I'm going to click on this icon. This icon means that play or run simulation. So I'm going to run the simulation here. I'm going to click on it. At this point, this circuit schematic has been described using something we call netlist. So I can show you the netlist here. And if you look into the output and you click into this icon here, this is going to be the netlist. Basically, this is the description of the circuit. So this is what we call netlist, and that's something that has to deal with the history of PSpice. When I was studying electronics many years ago, decades ago, we used to describe the circuits as netlist. Now we describe the circuit using the schematic, which what we just showed you over here. So now we describe the circuit using the drawing or the schematic, but PSpice need to use that netlist. It basically says that this circuit have been converted into a circuit description for PSpice. Now the simulation is completed, and the netlist is generated, and the simulation is completed. Now if you're using bias point simulation only, you come to those ones here. It will show you the bias point voltage, the bias point current, and the bias point power. So you can toggle it on and off. So I'm going to show you the voltage, for example. If I'm going to click on this one, it shows you that the voltage on the top is 15 volts and the voltage at the ground is 0, which we expect that because we have a 15 volts voltage source. So if I click on the second icon, that where it says enable bias current display, it will show you the current. So if I click on it, it will show me the current. So the value of the current here says 7.5 milliamp. It shows you the side where the current will enter the element. So the resistor will have the current entering from the top side. The arrow will enter the top side and will be 7.5 milliamp. And for the voltage source, the current will enter from the bottom side. That means it leaves from the top side. And the value is 7.5 milliamp. Now, if I wanted to know the power, I'm going to click on this one where it says W, and that will enable the power display. So I'm going to click on it, and it will show that the power for the voltage source is negative. That means it is delivering or supplying power. And this will be negative 112.5 milliwatts. And the power absorbed by the resistor is positive. It's 112.5 milliwatts. Now keep in mind that the convention for us is consistent with PSpice. If the power is positive, it means it's absorbing or dissipating power. If the power is negative, it means that it is delivering or supplying power. So this is consistent with our conventions. And basically here what we did, we were able to build a very simple circuit like a voltage source and a resistor. And we used bias points simulation to simulate the circuit, which means that it's the DC values. It's showing us what's the DC values are. The bias points means DC value. Now what I'm going to do is I'm going to create a new circuit. So I'm going to basically move the circuit over here, and I'm going to basically toggle the display of the voltage, current, and power by clicking on them. So you can toggle them on or off, basically. And now I'm going to start a new circuit. So I'm going to start with a voltage source, so VDC. And this is going to be called VDC2. And I'm going to give it a value of 10 volts. I can give it any different value I want it. And now I'm going to also add a bunch of resistors, not just one resistor, but I will add a bunch of resistors. So here is R. So I will add one resistor here, and I click on it. And then I'm going to add another resistor here. And then I'm going to rotate, and I'm going to add another resistor here. So I'm adding 3 resistors, and it's going to give me some T-shape. Then I'm going to connect those elements together. So I'm going to click on place wire. I'm going to connect this voltage source to this resistor to that, and those 2 resistors to this. And make sure that all the elements are connected. Then I'm going to add another wire to connect the 3 elements together, like this, and like that. Now I can change the value of those resistors. So let's make this resistor, for example, 4.7K. So I'm going to do 4.7K. I'll hit enter. Let's make this 2.2K. And let's make R3 to be 10K. Now this circuit is not complete yet. I need to place a ground. So I will click on the ground. Then I will add the ground here at the bottom. So this is the circuit I wanted to simulate. I can move the resistor to the top here and this resistor to the top. Make the circuit a little bit symmetrical, kind of. Maybe move this one a little bit farther. Okay. So this is the circuit I wanted to simulate. And now I'm going to come back to the simulation. So not this one. This one will add a new simulation. I will come to edit simulation. I will click on it. I will keep it the same as it is. I just wanted to show you that you can come back to the same simulation. I will make sure that I'm using bias points. And then I will say, okay, I'm done with that. So now I'm going to run the circuit. And now because those 2 circuits are in the same schematic, it's going to re-simulate the old circuit and the new circuit at the same time. So let's run the simulation. And now the simulation is complete. So now I wanted to show the voltage values. So you can see that for this circuit, the voltage here is 10 volts. The voltage here is 2.773 volts. The voltage here is 0. I'm going to turn off the voltage measurements. I'm going to click on the currents. So, and those are the currents that we have. The current enters the voltage source from the bottom will equal to 1.538 milliamps. The current enters the resistor from the left to the right. It's the same as the voltage source current. And then we have current enters R4 from the top, which is 1.26 milliamps. And then there is current enters R3 from the left to the right. So the current goes this way, and that will equal to 2.773 microamp. 2.77.3 microamp. So And here we basically were able to simulate a more complicated circuit. You can do the same with the power. Now it will show us that the power is negative for the voltage source, and resistors always absorb power, so that's why we have in positive values. But you will be able to read the voltage and the current and the power of each element. Now, one more thing about the voltage I need to add. The voltage in PSpice will give you the voltage at the node. So the voltage across this resistor going to be 10 minus 2.773 volts. So roughly around 7.23 volts, the voltage across R2. Because PSpice will give you the voltage at a node. What's the voltage at this point in reference to ground? And what's the voltage at this point in reference to ground? In either case, this is a very basic introduction to basic circuit simulation using bias points. I hope you enjoyed this video, and good luck to you.